Okay, guys, page 58, chapter 9, Magnetism. We've got vocabulary at the top. Domain, a group of atoms whose magnetic field are lined up in the same direction. Electromagnet, a current-carrying coil of wire with many loops wrapped around a magnetic rod. Solenoid, a current-carrying coil of wire with many loops. Almost 200 years ago, a scientist named Hans Christian Ørsted discovered that magnetism is produced by moving electric charges. In other words, electric currents create magnetic fields. Moving charges cause magnetism. Remember, electrons are the tiny negatively charged particles that make up atoms along with protons and neutrons. Electrons spin around like tops. As they spin, they create tiny magnetic fields. However, electrons spinning in opposite directions cancel out each other's magnetic fields. This happens in most substances, which is why most objects are not magnetic. In certain metals like iron, nickel, and cobalt, the fields do not cancel each other out. These metals are magnetic. Magnetic atoms rotate to line themselves up with the magnetic fields of nearby atoms. This lining up of atoms forms domains. A domain is a group of atoms whose magnetic fields are lined up in the same direction. The magnetic fields in the domains of a non-magnetized piece of iron are not lined up. When a strong magnet is brought close to the piece of iron, the iron's domain line up with the magnet's magnetic field. The piece of iron becomes magnetized. You can make a magnet. Rub a piece of iron with a magnet and the piece of iron will become magnetized. A magnet can also become a weaker magnet, or not magnetic at all. If you heat a magnet to a certain temperature or drop it hard enough, some of the atoms in the magnet will rearrange themselves. This causes the object to lose magnetism. Electric current creates a magnetic field. If one moving electron creates a tiny magnetic field, imagine what a current of electrons flowing through a wire can create. A current-carrying wire creates a magnetic field that exerts a force on magnets. For example, look at the picture on page 59. A compass is placed next to a complete circuit. The circuit has a current flowing through it. The flowing electrical current creates a magnetic field. When you place a compass next to a circuit that a current is flowing through, the needle of the compass will move. The tiny magnet of the compass needle will line up with the magnetic field of the wire.